Good afternoon, everybody. Welcome. It's good to see you. So today we're going to study a arcane area of computer systems known as floating point, which is the way that computer systems represent the real numbers. So you're all familiar with decimals, something like 3.14, and there's a similar idea with binary numbers. Okay, so what does a fractional binary number like 1011.101 represent, and how does that work? Well, it works just like the fractional decimal numbers that you're used to.
Wait, fractional. Oh, we know what a fractional binary number is. So when you look at a binary value, right? So when you look at a binary value, you're gonna have 2 to the power 1, 2 to the power 0, 1, 2, 3, 4, 5, and so on. From the back, you're gonna have 2 to the power 0, 2 to the power minus 1, minus 2, minus 3, minus 4, so on and so forth. Right? This is lecture 4. This will be chapter 1.2.1. Am I right? Yes, it should be 1.2.1 because I have not done 1.2. Yes, it should be 1.2.1. Oh no, I have my own monitor here, so I can literally see from here. Yeah, I'm going to say it's duality that today I got my own monitor. Understand? Like I got a Lenovo monitor. It's a very powerful monitor. I got a monitor for myself. Can you imagine? I got a monitor today. Can you imagine? My own university provides me a monitor. Wow. A Lenovo. This is Lenovo ThinkPad L. What 240? Wait, Lenovo. The box is literally right there. Lenovo ThinkPad T240, right? Is it? Yeah, T240. Yes, Lenovo ThinkPad. The Lenovo ThinkPad T240 40. Very good monitor. Maybe I am not a deadbeat, I guess.
So you have in this case, it's a binary point, and to the left of the binary point, you have bit positions representing powers of 2, so 2 to the 0, 2 to the 1, 2 to the 2. So 1/2, I'm sorry, 1, 2, 4, and so on. And to the right of the binary point.
So what I'm going to do is, I did this while I was doing my aerospace book. When they teach, like when this AI teaches, like do the latex explanation, and based on like do the latex explanation, like what I want to do is, where's the abstract? Open the abstract. Based on the abstract, write that latex explanation. So less maths, less English, more maths, so that any students around the world can understand. That's my goal. Let's see, open. So can you write a latex code for this explanation for my book? So what I want is write the latex code. So write the latex code, and I am going to read the latex code and understand from there. That way, not only I understood, but the book chapter, will also be finished simultaneously. I want explained in such a way that students in any computer engineering or computer science background can understand easy. So meaning less math, less English, more math, and the English have core explanation. Oh yeah, my monitor is right here, so I can see it from here too. That's completely fine. My monitor is here too. Yeah, I'm not a deadbeat, right? Yeah, you guys can see from here. I don't have to do that. I'm not a deadbeat, so okay, what is this? Come on, man. This is not good. The latex code, what is this? What is this, man? Come on. Do better. You don't know how an academic book is written. So, okay, I have to take screenshots again and again and again and again. It is kind of annoying because it doesn't remember the next thing. It only remember, like, say, for example, if you use one chat, it's going to only understand that chat. But whatever you want to explain the next one, it doesn't understand that because it completely forgot. So let's say, for example, here you see more English, right? You see like so many words and stuff like that. I don't want that. What was that, man? Come on. So the structure of the book will be formal. So the structure of the book will be exactly like the images, but rather than more English, have less English, and more maths. English part only have the core explanation, like core, core explanation, core general equations, core teachings and stuff. Okay, so it'll actually. Hmm, I hope this is good because we also have other things, right? Yeah, no, it didn't work. Yeah, no, it didn't work. It didn't work. Yeah, you can't work. Shit, not good. I don't know what happened to you. Yeah, even then it's not going to work. Even then it's not going to work. I can pretty much tell. Even then it's not going to work because of because these brackets and whatever. I can already tell it's not going to work. I pretty much figured out it's not going to work. So what I'm going to do is actually go to DeepSeek or Grok. Yeah, I figured out. I figured because of these brackets and stuff. Yeah, yeah, it didn't work. Anyways, yeah, you couldn't work. That's sad. You couldn't do it. I don't know why am I wasting my time. So here, let's go to DeepSeek. DeepSeek and Grok. These two are like really good, dude. We didn't do. Yeah, bro. I don't have to copy paste. I don't have to. I know it's not going to work because again, these brackets exist again. It's not going to work. Totally, it's not going to work. So I don't know what the fuck is this. Can you fix it? No, I mean fix the latex code and have the modified latex code so that I can copy it. Please, just fingers crossed, fingers crossed. I hope this works. Okay, I don't know why are you going to nmap. Okay, also I don't understand. Also, I don't understand why are you going to nmap directly when we are just at chapter 1. Why are you going to nmap directly? It is very weird. You're going to nmap directly. Do you see that? Like, this is not good. This is not good. And you're also using aerospace. I don't know what are you doing. I don't know what are you doing, but yeah, I don't understand what is he doing. Anyways, I'll be. Let me finish this first. Yeah, I, I don't know what is he doing.
You have 2 to the minus 1, 1/2, 2 to the minus 2, 1/4.
Yeah, I don't know what the fuck is going on. Like, I genuinely don't understand what's going on. Yeah, I don't know. What are you doing? Yeah, dude, I don't understand what you're doing. I genuinely don't understand what you're doing. Yeah. Um, So this is section 1.2. So we're going to start with 1.2. We are going to start with chapter 1.2 now. If you do remember the abstract, please. Oh, you won't remember the abstract. You will know it's not going to remember the abstract. Create a latex code based on the abstract and slide. Now remember, this slide is one of many slides, so calm down with the explanation. Let's see how good you are. It's a test. It's a test. I know he's going to explain nmap now. Oh, it went to okay. Um, we're only focusing on 1.2.1 now. So this entire timeline, okay, so it directly went to 1.2.1, which I don't know why did it do that. I never said it, but must understand that this is ChatGPT, right? This is a dumb model. So I pretty much there'll be many mistakes. One, I don't know why are you doing um section. Okay, actually, you know what? I have an idea. I have a good idea because this is very stupid. So you have to play the stupid game. So I'm going to copy the entire transcript and say finish the entirety. You know what? Finish the entirety of section 1.2.1 based on the abstract and the notes from second pasted text. Let's see if it can do it. It can't. It cannot because uh, obviously it's way too many, right? And on top, I can already tell there, there. That's wrong. That's wrong. This is wrong. This is wrong. These are wrong. So we're going to get an error. I figured out. I figured out. If we don't get an error, I'm gonna pay. I'm gonna pay $200 per month. I told you. I told you. There will be error. I told you. There's no way you're not going to have errors. I told you. If there will be errors, I'm gonna pay $200 a month. It doesn't understand. It literally doesn't understand. It's not understanding. It's not understanding. Believe me, it's not understanding. I'm gonna get the same error because I literally see the same thing. I'm going to get the same error. What did I tell you? What did I tell you? What did I tell you? Come on. Can you read the PDF pasted text? No, you can't. You cannot. Why are you telling me you do it? The only reason I want to do the latex code first is because if you do it, then learn it, then do it, then learn it, it's kind of useless and it's going to make mistakes. You're going to waste a lot of time. And there is another mistake. I mean, I figured out. I already figured. I already figured. Where's the document, right? There will be nothing. There will be nothing, obviously. So I don't know why is he, okay. Yeah. Uh, yeah. I don't know what are you doing. I don't know what are you doing, man. Are you a Mossad agent? Are you controlled by someone that you are not allowed to help? Like, what are you doing? What are you doing? Are you drunk? Are you high? I don't know what's going on. I don't know what's going on. Then can you do the entire latex document and stop being a bitch? Title name. You literally went title name. Oh my god. Oh my god. He messed up. Stop, 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 stop. Stop, 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 stop. Stop, stop, stop. You messed up. You messed up. Finished. You messed up. I only said I only said chapter 1.2.1 and you're going all the way from the beginning. You messed up. You messed up big time. It's very dangerous. Very dangerous. Good reason why Trump didn't use your model for the DoD. Very good reason. Very good reason. So I'm gonna ask Grok. All I'm going to do is ask Grok. The best thing you can do, ask Grok. So this is my abstract. I was wondering if you can write the latex code for the pasted text for my academic book based on the abstract and set it chapter 1.2.1. Now obviously chapter 1.2.1, like you can't have advanced stuff because they just begun. They're the students from computer science and computer engineering have just begun, right? So playing their mind, have less English, more maths, and the English must only have core explanations, core equations, core examples and stuff. ChatGPT couldn't do it. He couldn't do it. I'm trusting you. Huh? 2003. There's a good reason why I trust Grok. There's a very good reason why I trust. If this works, no, it didn't work. Oh wait, there's a good reason why it didn't work. I didn't copy it. Yeah, I'm like, what the fuck am I doing? What? Wait, what am I copying? This, right? Ah, man, it didn't work. Yeah, I mean, I can tell it's somewhat working, but no, it didn't work. I don't know what's going on, man. It didn't work. No, I'm not going to ChatGPT. Nope, no way. I can pretty much tell this will also not work. Reason being is because yeah, I don't think it's going to work. I have a bad feeling. I have a very bad feeling it's not going to work. I have a bad feeling it's going to work. Yeah, I figured. Man, I'm getting so many errors. Why? Yeah, I'm getting way too many errors. Man, I'm trusting you, man. I'm trusting you. Okay, I understand why. It's not because of the latex code. It's because now I understand. Now I get it. Now I get it. Uh, let's save this in cybersecurity. This will be chapter 1.2.1. Install. Install. Okay. It didn't. Did it work? Did it work? No, I didn't. I don't know if this means it worked. Yeah. No, he did mention that don't copy it in the latex code. Like don't copy it there. There you go. So it will be 1.2. It'll be 1.2, right? It'll be 1.2, not 1.1. It'll be 1.2 floating point representation. So the chapter name, let we just wait. So the chapter name will be floating point systems and machine learning foundation. So that'll be the chapter name. I got it. Wait. It worked. Wait. Don't worry, I'm going to take time. The floating point systems and machine learning foundation. It worked. Wait, it worked. But can you change it to 1.2? What was the name? Floating point systems. 1.2 floating point systems and machine learning foundations. And then start with 1.2.1. And like only have 1.2 and the next one will be 1.2.1. Like 1.2.1 floating point representation. And then have 1.2.1 floating point representations, and then no more numbers, and then no more like 1.2.2, 1.2.3. No need, because that's separate. It worked. Grok is really good for this, like for editing like latex code and whatever. Go for Grok. For explain, remove the 1.1 and 1.1.1. See, remove them. Look. See the 1.1 and 1.1.1. Remove them. You see the 1.1 and 1.1.1. Remove them. Don't have them. But I don't think it'll be the same for others. The 1.1.3, 1.1.4, 1.1.5, 1.1.6. I don't want any 1.1 there. Okay, I need, yeah. Pretty much he removed the 1.2. So when you look at the, yeah, he did it. That's fine. So, but when you look at the code here, okay, let me go to ChatGPT now. Let's see if they can do it. Let me see if they can do it. Can you remove everything that has 1.1 in it and have it as 1.2? Oh, it is still focusing on the microphone. I don't know why is it still focusing on the microphone. Again, it's ChatGPT is very very old. Yeah. Um, can you move everything that has 1.1 in it and replace it with 1.2? And replace it with 1.2. Rest I'm going to do the changes. I'm going to do the changes because it's not able to do it. That's it. Oh my god, no, I meant modify the entire code. Have the entire code, not just one thing. Come on, you're wasting time. You're wasting time. So this guy wasted, I don't remember how long did he wait, but I would have to extend my time. Yeah, I think he made it worse. He made it worse. He made it worse. I can tell he made it worse. He made it worse. I can already see it. I can already see it. He made it worse. Please, I just hope he didn't make it worse. Fig- I figured he made it worse. Oh my god, he made it worse. He made it worse. Why? Okay, why do you want to make it worse? Come on. Come on. I paid you. I paid you. No, you do it, man. Oh no. Now, can you have the entire code again with this modification? Nope. They're only going to paste that one itself. Oh no. Oh no. Oh no. Shit. I can already sense that something is going to go wrong. Something's going to go very wrong. I can already sense it. I can already sense it. Oh, we're cooked. We are cooked. I figured. So it doesn't remove that 1.1 and that 1.1.1. It didn't remove it. So let me manually go to the code. And where's that 1.1? So I have to manually change that. Yeah, even you weren't able to remove it. So even you were not able to remove it. That 1.1 and 1.1 is still there. But yeah, I mean, this is your limit only. This is your limit. Yeah, it is. Yeah, it's not able. He will not do it, even though I paid him to do it. Remember, I paid him to do it. But let's understand, paying a model to do it does not mean the model will be able to do it. So now let's run it. Thank God, now it worked. All right. It somewhat worked. But this is only the first part, right? Yeah, this is only the first part. Even though I copied the entire thing. Reconnaissance systems continuously process probabilistic from information, confidence scores, uncertainty measure, Bayesian estimations, and dynamically evolving infrastructure states. So for example, 0.25, 0.5, 0.875, 0.991. Computer hardware cannot directly store decimal fractions. Instead, all fractional values must be encoded using binary maths. And the binary fraction representation, so it'll be in, so it didn't, so I think, mm, yeah. Um, mm, how do I? Yeah, I already know what's going on. Um, how do I, like, like when you do a binary, like when you do so I understand what's going on. I understand what's going on. Um, but how do I, add that table, right? The table, like that segregates to the power 0, to the power 1, to the power 2, to the power 3, so on, so on, so on. And the same goes for the previous values. No, I meant hmm, like a box, right? Like let me show it on paint. Um, again, it's not able to understand, so it's like this. It'll be like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, something like this. I don't, it's not able to read it, but do you get the point or not? I don't think you don't. Like, I don't know if you understood the image. I don't think you did. I don't think you did, but this is what I am referring to. This is what I'm referring to. I don't think you understood the image. Yes. Um, can I, by any chance, copy the entire thing and paste it here? I don't think it's going to work because the way it works in LaTeX online compiler and the way, okay, it actually worked. That is very surprising. So there. So a binary fraction has the form, so I would have to change that instead. There you go. That's what I want. And then so on and so forth. So bits to the left of the binary represent the positive powers of 2. Bits to the right represents fractional powers of 2. So if I have 101.101, then I'm going to have 1 times 2 to the power 2, 1 times 2 to the power 1, 1 times 2 to the power 0, 1 times 2 to the power minus 1, 0 times 2 to the power minus 2, 1 times 2 to the power minus 3. That is really good. That is really, really, really good. That is amazing. That is amazing. And then shift operation. So shifting the binary point one position to the left divides the number by 2. One position to the right multiplies by 2. So if I have 1.01.11, what this means is that 1.0101.11, what I have to do is 1 times 2 to the power 2 plus 1 times 2 to the 0 times 2 to the power 1 plus 1 times 2 to the power 0 plus 1 times 2 to the power minus 1 plus 1 times 2 to the power minus 2. Now, obviously, 1 times 2 to the power minus 1 plus 1 times 2 to the power minus 2, it is 0.5 plus 0.25, which is 0.75. And here, because I have 2 to the power 1 and 2 to the power, no, not 2 to the power 1, 2 to the power 0 and 2 to the power 2, which is 4 plus 1, which is 5. Makes sense, right? It makes sense. And the limitation of fixed. So the fixed point representation possesses two major limits. Only the numbers of the form x by 2 to the power k can be represented exactly. There exists a trade-off between range and precision. I didn't understand this part. I don't understand the limitations. Uh, I don't understand the limitations. Can you explain using maybe 2 or 3 examples? So if I have 0.5, which is half, the binary is 0.1. Yeah, the binary is 0.1 because you have 2 to the power minus 1. Makes sense. So you'll have 0.11 because the denominator is 2 to the power 2 square, right? Now consider 1 by 10. The 10 is not 2 to the power k because can you have? So the binary cannot terminate nicely. So binary will become 1 by 10 is what? 0.1. Why? Oh, yeah. Because 2 to the power, so you need to do like log base 2 10, which is like some weird value, and then you have to do a binary for that which never stops. So the computer must cut somewhere. This creates a rounding error, approximation error, or precision loss. And suppose this program computes the p of probability of malicious is 0.1. So internally the machine cannot store exact 0.1. So the small estimation errors appear and the confidence score will drift slightly, meaning, and there will also be repeated computations will accumulate error, meaning if I were to compute again and again and again and again, then what happens is that I'm going to keep on having more and more and more errors because, like, for example, 0.1 is 1 by 10, but the 10 2 to the power something doesn't equal 10 because 2 to the power what equals 10. Like, there is a value, but it's not like it's a nice, like, calm value, right? No, I understood. I understood. So suppose you only have 8 bits, you must decide more bits before this decimal point or more bits after the decimal point. You cannot maximize it. So suppose all of them are 1 and binary point ends at 0. So the largest is 2.255, but the smallest fraction value can be 1. So you cannot have 0.5, you cannot have 0.25, you cannot have 0.1. It must be 1. The smallest possible fraction is 1. Yes, 1.0, which is, yeah, 1. 1. That's the smallest possible fraction. High precision, so move binary points. You're gonna have one point, all the one. So you have what? 2 to the power 1 plus 2 to the power 0, so that's 3. And then 2 to the power minus 1 plus 2 to the power minus 2 minus 3 minus 4 minus 5 minus 6. So the maximum value now is that, right? It is good, but very small range. But precision is really good. 1 by 64. Yeah. Is it? Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 2, 4, 8, 16. Yes, 1 by 64. The precision is really good because it's going all the way up to 2 to the power minus 6. The more integer bits, larger numbers. More fractional bits, better precision. Cannot maximize both. The more integer, larger the number. More fractional, better the precision. can we write this? I actually understood without, believe me, like, I swear I understood this without writing a single thing on my iPad. Can I have this exact explanation as latex code? Please. I fucking understood without writing a single word. That is really good. That's really good explanation. Like, I understood thoroughly. I hope you guys understood. She alive or what? Dude, 4 hours ago. Are you alive? Dude, 4 hours ago. Oh, it's still there. Oh, the limitations. So instead of this, um, all those, I'll change it to this one. So now you actually understood way better. The so the exact representation constraint. So fixed points can only represent the numbers of form. This means the denominator must be a power of 2. So consider that 0.5 means half, half means okay, yeah. I fucking understood. I fucking understood. Let's go to the IEE part. So any non-special floating point number is written as that. Okay. No, it's fine. I was hoping if you can use and like maybe 3 examples, maybe to understand it better. I was hoping. I was hoping if you can use 3 examples to maybe make it understand better. Um, nope, here. So any non-special floating point number is written as -1 to the power s times m times 2 to the power e, where what? Oh, there. Boom. So the what's IEEE? What is IEEE? Ho ho, Institute of Electrical and Electronics Engineers. So Institute of Electrical and Electronics Engineer. Oh, shit. Institute of Electrical and Electronics Engineering 754 system stores floating point numbers using three components minus 1 to the power s times m times 2 to the power e, where s is the sign bit, m is the significant bit, e is the exponent bit. The system is fundamentally scientific notation in binary form. So consider 5.75, that's in the round of tens. So it's a value. It's a real value, right? So when they say 5.75 base 10, it's a value, not a binary, but a value. So we're going to convert that into binary. So 5.75 is what? 5 is what? 101. 0.75 is 11. So obviously, so where is it? So I'm just going to write here, just use the so use the the table, use the binary table. Well, use the use binary. Oh wait, what's going on? Use the binary table and segregate the binary values. Wait, I know that there will be no space. I can literally see it. Why is that? Okay. How do I change this? When I write this in the latex code, it doesn't indent or add space in between. Why? There. That is really good. That is really, really good. Dude, man, I'm telling you, you are going to understand section 1. I mean, you hate me, I can already tell. I know you're going to hate me. But man, the chapter 1.2 for cybersecurity, you will understand. You will understand. It is so good. You will understand. I promise you, you will understand. I'm telling you. I'm telling you. I'm telling you. You don't need iPad to write your notes. You will understand. My entire plan is to make sure nobody uses an iPad. They can read and understand. So the sign bit, the number is positive. The number is not positive, the number is negative. Is it positive? I don't think is it positive? You sure it's positive? I don't think it's positive. It's negative. I'm curious, why would this be positive? Why would 101, I know. 101.11, the binary part, why would that be positive? The sign bit, let's focus on the sign bit. The sign part, the sign bit. Why would that be positive? So the binary value ended up as 101.11. But why positive? Yes, I know, but doesn't it start from 1? Oh, okay. It makes sense. Makes sense. Okay, because the number is positive, 5.75 is the positive value. If I had minus 5.75, we do the same thing, but your S would be 1. So the normalized binary would be 1.0111. Yeah, 1.0111 times 2 squared. It only stores the 0.0111 because the leading 1 is automatically assumed. Hmm. So the normalized binary becomes 1.0111, and the IEEE 754 will only store the 0.111 because the leading one is already assumed. This is already assumed, automatically assumed. Sorry, the exponent value. So E is equal to 2. Can is it possible? Is it possible to do the same for negative value and convert that to latex code? I'm genuinely happy for this book. I'm really happy for this book. Like I can assure you, people will understand. People will understand this shit. There is no way you will not understand. No way, no way. And the negative values. Consider minus 5.75. So first convert the magnitude to binary. And then now, because it's minus 5.75, there's going to be S will be 1 now. So let's say exponential value E is equal to 2. Single precision uses bias. So 127. Thus, stored exponent would be 129. Convert this into binary. 129 would be that. So you're going to have 1. This is for the negative value. So 1, and then the binary for exponent value. What is that? Oh, 0, 1, 1, 1, and then all of them 0. Yep, I understood. I'm just going to go here. Where is it? I'm just going to write or 0. So I'm just going to copy the same thing. 0, or so this is for the okay, for the negative 5.75, and this is for the positive 5.75. For the negative 5.75 or for the positive 5.75. So 1 point whatever the value is times 2 to the power whatever the exponential value is. I don't understand the Mm. And single precision like 32 bits. So you're gonna have one. Okay, this. Yeah. 1.01101010101, all of them times 2 to the power whatever the exponential value is. So here it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 point all those values multiplied by 2 to the power 11. And single precision and double precision. Yeah, I'm going to do that. I'm going to do that. Can we do an example for this? Can we do 2 examples for each? Can we do, come on. Can we do 2 examples for each? Dude, I am genuinely excited for this. I am genuinely, like, genuinely excited for this. Well, I think what I have to do is remove all those and have one. The single precision uses 1 sign bit, 8 exponent bit, 23 fraction bits. So total will be 32. So let's say 5.75. So 5.75 would be 1.0, 101.11. So 101.11 would be 1.011 times 2 to the power 2. The positive number is 0, so the exponent here, exponent is 2 because 2 to the power 2. E here is 2. And the single precision bias is 127. And so the stored exponent will be 129. The binary will be that. The fractional portion is 0111. And the pad to 23 bits. So you're going to have 0111, all of them zeros. And the final 32-bit representation will be 0 because that's the signed integer value. That's your binary value for 129, and the 0111, all of them zeros. Double precision uses 1 sign bit, 11 exponent bits, and 52 fraction bits. So total will be 64. So double precision allows much larger numerical range, much higher precision, reduced rounding error. And so let's say 9.5. So 9.5 would be 9 would be 1248. So 1001.1. So 1.0011 times 2 to the power 3. So your exponential is actually 3, right? So 3 plus 1023. So double precision bias is so 1026. So it'll be like phew, right? Holy fuck, you explained so well. How? How do you explain so well? How? Dude, how? Man, I did not write a single note and I understood. dude, I don't have to even read it. What? I don't even have to read it. Man, if only people knew that I'm actually writing a book. Only people knew. You're missing out. Like, I'll say it to Valentine, I'll say, you're missing out on so much stuff. Like, you're missing out. Like, do you understand? You're missing out on so much. You're missing out on so much valuable information. Imagine you took your time. Can you imagine people who people who boast about religion or IQ could take 10 minutes to learn cybersecurity? 10 minutes. 10 minutes of their time. Oh man, only you and I will understand how valuable 10 minutes is. You understand how valuable, how much you can learn from 10 minutes only. 10 minutes. Only 10 minutes of cybersecurity. And you learn a lot. 10 minutes. Only 10 minutes. Valentina is a different beast. Valentina is a different beast. So don't don't correlate with her. She's a different beast. But to the others, you have 10 minutes of your time. But yeah, I know Valentina will not care. 'Cause at the end of the day, like, well, can you explain this part with, examples if you don't mind?